Chapter 5, Section 2, Day 2, Probability Rules. After today's lesson, you should be able to determine probabilities from two-way tables and construct Venn diagrams and determine probabilities from them. When finding probability involving two events, a two-way table can display the sample space in a way that makes probability calculations easier. Consider the example on page 303. Students in a college statistics class want to find out how common it is for young adults to have their ears pierced. They recorded data on two variables, gender and whether the student had their ears pierced for each of all the 178 people in their class. The two-way table below displays the data. For this problem, I'm going to define two events. Event A, I'm going to define as being male. And event B, I'm going to define as having pierced ears. I want to find the probability that the student, A, has pierced ears. When I calculate this from the two-way table, you can see that there are 19 males and 84 females that have their ears pierced. Adding those together, you have 103 total students with their ears pierced, divided by the 178 would give you the probability of B, which is having their ears pierced. Next, part B, I want to find the probability that the student is a male with pierced ears. From the table, you can see the probability of being a male and having your ears pierced is 19 total students divided by the 178 total students. Part C, I want to find the probability that the student is male or has their ears pierced. We want to find the probability of male or ears pierced. That is the probability of A or B. There are 90 males in the class and 103 individuals with their ears pierced. However, 19 males have their ear pierced, so I don't want to have to count them twice. So the probability of A or B, meaning male or has their ears pierced, would be 19 plus 71 plus 84, which is 174 divided by 178. Note, the previous example illustrates the fact that we cannot use the addition rule for mutually exclusive events unless the events have no outcomes in common. The Venn diagram below illustrates why. If you take a look at this, you have a large rectangle that's yellow that represents the entire sample space. Inside there are two circles. The yellow circle is event A, meaning male. Event B is in blue. There is an overlap where the yellow and the blue circle overlap. And that is the event A and B, which is where the males have their ears pierced. If you were to just add the two numbers together, the 90 and the 103, you would end up with 193 out of 178 students, which is impossible. The problem here lies from the fact that you're double counting the males with their ears pierced. There is an additional rule for addition, and it's the general rule for two events to occur. If A and B are any two events resulting from some chance process, then the probability of A or B occurring is the probability of A plus the probability of B minus the probability of A and B occurring together. This general addition rule for two events could also be used for events that are mutually exclusive. It's just that the probability of A and the probability of B would be 0 in that case because they would not share any common outcomes. Because Venn diagrams have uses in other branches of mathematics, some standard vocabulary and notations have been developed. We have talked about complements before. The complement of A complement, contains exactly the outcomes that are not found in A. The events A and B are mutually exclusive or disjoint because they do not have an overlap. That is, they have no common outcomes. The intersection of events A and B, noted as A intersect B, is a set of all outcomes that are in both events. The union of A and B, labeled as A union B, is a set of all outcomes in either event A or B. To keep the symbol straight, remember U is for union and N is for intersection. Recall the example on gender and pierced ears. We can use a Venn diagram to display the information and determine probabilities from the Venn diagram. Again, define events A as male and B as having pierced ears. Event A, you will notice in the Venn diagram, has a total of 90 within that circle. Event B has a total of 103 in that circle. There are 90 males and 103 that have a pierced ear. In the intersection of the two circles is 19, and that's where you have the males with pierced ears. There are only 4 females that don't have pierced ears, and they should be shown as that number 4 on the outside of the circles. In symbols, you can see below the counts that are within the different parts of the Venn diagram. In the intersection of the two circles, the male and the pierced ears, it's A intersect B, and there's 19. Inside circle A but outside circle B, meaning there's males with no pierced ears, it's A intersect B complement, so it's outside of circle B, and there's 71 there. Inside circle B but outside circle A, that means the females and pierced ears would be A complement, that's outside of circle A, but also inside of circle B, and that's 84. And then outside of both circles, female and no pierced ears, A complement and B complement, or intersect B complement, and there's 4 there. Quick summary of everything in section 5.2. A probability model describes chance behavior by listing the possible outcomes in the sample space and giving the probability that each outcome would occur. An event is any subset of the possible outcomes in this chance process. Remember, for any event, the probability needs to be between 0 and 1. The probability of the entire sample space must equal 1. If all outcomes are equally likely, the probability of an event A happening is the total number of outcomes corresponding to event A divided by the total number of outcomes in the sample space. The probability of A complement is 1 minus the probability of A occurring. Basically, that means it's the probability that A will not happen. Events A and B are determined to be mutually exclusive or disjoint if they have no outcomes in common. If A and B are disjoint, the probability of A or B happening is the probability of A plus the probability of B. A two-way table or a Venn diagram can be used to display the sample space for a chance process. The intersection of events A and B consists of the outcomes in both A and B. The union of events A and B consists of the outcomes in event A, event B, or in both. You can find the probability of A or B by adding the probability of A plus the probability of B, but subtracting the probability of A and B. This has been it for section 5.2. We'll finish up section 5.3 over the next couple of videos.